Hi viewers, Alan here again, back in the workshop after a bit of a layoff. I've been playing Florence Nightingale for my wife. She's of some 45 years. She has been having a bit of trouble with one of her eyes, so I've had to do a lot of eye drops and other bits and pieces. Anyway, things are looking up, so for now I'm back in the workshop. So what I want to talk about in this video is a very specific thing, which is how to find the included angle of this thing here. And I need to know that because I'm making up some pieces that are missing from a dividing head. One of them being this indexing ring, and it needs to have a set of grooves cut in it, or locating marks, and this pointy thing will engage in those. So I need to be able to make a cutter which will make a groove that matches that included angle. So the question is, well, how do I find out what that included angle actually is? I've had several different goes at it and come up with some different answers, but I'd be interested in feedback in the comments, how anybody else would have done this and whether there's some easy way that I've not seen. Anyway, I'll have a look at the first way I did it. Let's look first at my first attempt and see how that went out. So the first thing to notice is that you can't get a direct angle reading because I haven't got anything which will allow me to directly read that. So that's where all the problems start. So we've got to find some way of getting hold of this a little bit. So my first idea was to, well, let's just go super simple. Try and trace it onto a piece of paper with as little parallax error as possible. So I've got a shim there to make up that distance, and we'll just trace it on a bit of paper and see how well that works. And yes, it becomes possible to get some sort of a reading like that. Not going to be very accurate, but it looks like it's looks like that's the reading, which is the included angle is about 27. So that's my first try, included angle 27. But that really does seem a bit rough and ready. So I came up with another idea. My second attempt, I thought, well, if I set it up in a V block like that and use that as a spacer, perhaps I can get a direct reading like that off the protractor. Anyway, after a lot of fiddling and faffing about, best I could get with this method was to replicate the 27 degrees that I got from the tracing out on a piece of paper. I don't have a whole lot of confidence in this method either. So time for method 3. Let's see if we can get a definitive answer. Now for my third attempt, I've got the pointer set up in the milling machine. I'm going to use the DRO in combination with the DTI to trace across the face of the taper pin, and I'll go across 2 millimeters, and we'll see what the how much the DTI reads as the change due to the taper. Now I'm going to take my 2 millimeters out of the middle of the piece to try and avoid any issues with a corner radius here or fall off over there or whatever. And I've set this up using a set square to have this tapered face vertical. And the other thing I did was set the DTI to read on the equator or the centre line across that way to help obviate any misreading. So let's move across 2 millimeters by the DRO and see what the offset is. Right, that's 2mm, and we've got 0.53. So for 2mm track this way, the taper caused it to move 0.53 the other way. So I get some simple trigonometry onto that and work out what the angle is. Okay, so it turns out that with a rise, shall we say, of 0.53 over a distance of 2mm, that gives us an angle whose tangent is 0.265 millimetres, well, 0.265. And as it happens, tan 15 is 0.268, and I think that's close enough to call it, remembering that what I was measuring was a half of the included angle. So that would indicate that that included angle is 30 degrees. And that makes sense to me. I mean, why the hell would you make it 27 degrees? There's just no logic to it. So I'm going to call it an included angle of 30 degrees. And I didn't bother to record it, but I did actually run that test with the DRO and the DTI a couple of times and got some repeatability. And there was no way I was getting repeatability with either of the other two methods, fooling around with the protractor. So I'm calling that a done deal, and I'm ready in the next video now to grind a cutter, which will create 30-degree slots for this to nose into. That's it for now. I don't know how long it will be before I get back to do the next video. Some things are more important than others. Thanks for watching, and hopefully I'll see you next time.